Hello, I'm Professor Nick Salome here at Wichita State University. I have a radiation detector physics lab where we detect a lot of different type of particle detectors and different type of events, especially concentrate a lot on neutrinos. And I wanted to bring a new event that should be appearing soon to you. We have the possibility sometime in the next seconds to maybe September of 2024 to see a nova explosion. This is actually a repeating nova star. It's expected to detonate anytime from seconds from now to somewhere in September of 2024. It's last exploded with a nova explosion in 1946. So, what is a repeating nova? How's it different from a supernova? Well, first of all, we have a white dwarf star that's around a red giant. It's slowly accumulating mass from that red giant onto its surface. At some point, that mass is going to reach a critical density and a critical energy such that a nova explosion will occur. Now, this is not a supernova. This is a nova explosion. This is the hydrogen and maybe a little bit of helium gas around the white star building up to a critical amount. And the last time this occurred, it was estimated from the flash in 1946 that it was about the mass of the Earth in gas that was converted. And now, of course, the type of explosion will produce a gamma ray burst, lots of light. In fact, you'll be able to see a star for the first time in Corona Borealis. That's a constellation, and it's called, this star is T Corona Borealis, is its name. And you can't currently see it by the visible eye, but you can see it with a telescope or binoculars. And then it's going to brighten up to about a magnitude 2, which is pretty bright. So that's about the brightness of the North Star. And NASA has some simulations I'll share with you, and then I'll come back and talk to you about how this might affect my neutrino interest. So here's a red giant, and there's a star around it, and all of a sudden there's a nova explosion on that white dwarf star. It's massive. Like I said, imagine a hydrogen bomb about the mass of the Earth. It goes off. It's expected to go off anytime now, up through September of 2024. And you'll be able to see it with the visible eye for the first time in a long time. The constellation is Corona Borealis, for those astronomer fans. M13 is right here in the constellation of Hercules. Arcturus, or Vega. Here's Vega over here and Arcturus over there. These are two very bright stars every amateur could find. And Corona Borealis is this little arc ring like a crown. And in this constellation, you will see a brand new star. There's only 7 visible stars in this current constellation. You'll start to see an 8th one when this happens. Okay, so that's exciting. A lot of ways, it's not often you could have an event that's a repeating nova. So what effects does this have on us? Well, it's 3,000 light years away, so it's not going to have any effects at all. It's like I said, it's about the mass of the Earth that's being fused, mostly hydrogen with a little bit of helium, and it will produce neutrinos in addition to the gamma ray burst, in addition to the light burst. And the neutrinos, they're just going to be fusion neutrinos. So the same type of neutrinos that our sun is producing, it will produce. These are low energies, usually less than 8.5 MeV of energy, with most of them sitting at 1 or 2 MeV with a few lines. Now, of course, this is condensing lots of matter onto the surface of that white dwarf. And some of that matter is going to add to the mass of that white dwarf. Right now, that white dwarf star is estimated to be 1.37 times the mass of our sun. The Chandrasekhar limit is 1.39, and 1.39 is the mass that white dwarf star would have to have or go above that Chandra limit, and then that whole star will implode down to a neutron star. And now that will produce very, very energetic, and 3,000 light years away, that'll be brighter than the moon if that white dwarf was ever to collapse into a neutron star. And which could happen every time you keep accumulating mass and you keep accumulating mass onto a white dwarf. Eventually, it will happen. But it's probably trillions of years away, the rate at which it's a small amount of mass being added. So the other aspect of it, not only is it less energy than a supernova neutrino burst, whereas supernova neutrinos will be hundreds of MeV, whereas this is just a nova explosion producing just fusion of hydrogen, like a hydrogen bomb, by the equivalent to the mass of the Earth. And this will then be producing only solar neutrino level energies up to 8 MeV. Now, at 3,000 light years away, we've done a calculation and we conclude that the number of neutrinos from this nova explosion, even though it's a huge explosion, is going to be 5 orders of magnitude less than the amount of solar neutrinos we're getting directly from the sun. So there's no hope any experiment will see neutrinos from a nova explosion at that distance. However, if it does go over the Chandrasekhar limit and the entire white dwarf collapses into a neutron star, then that would fuse all of everything and make a neutron. That'll then force the electrons into the protons to make neutrons and produce a lot of neutrinos as well. So that could be an interesting event. Certainly not predicting that, but the nova explosion, look for it. And yeah, there will be neutrinos. Yes, there will be a gamma ray burst. Yes, there'll be an X-ray burst. By the way, the X-ray burst always occurs long after the neutrinos have started to fade. Let me share one more thing with you. I'll just share this with you. There are actually 10 repeating novas in our known local area. And T Corona Borealis is here on the list. It was, of course, originally predicted to be next occurring in 2022, which didn't happen. And now there's a new paper out that says it'll occur somewhere between February of 2024 and September of 2024. So, and we know it hasn't happened yet. But there's others. That's 3,000 light years away. There's the V394 Coroni Australis, which is expected in early 2025. It's only 120 light years away. So that'll produce more low energy neutrinos. It won't be anything like supernova again. It's even though it's 120 light years away, much, much closer than the 3,000 of T Corona Borealis. It too would not be more neutrinos than we get from our sun directly. So sorry, guys, but still, it's an exciting event. So thanks. Bye.